Hello and welcome to the IW. Today I will share with you a short story about pipelines for automating and scaling integrated digital engineering. I am Manas Bajaj and I'm the Chief Systems Officer at Intercax, commonly known as a good-hearted troublemaker. All of us here are well aware of CI/CD pipelines in traditional software development. Hey, I use it every day for my code. However, traditional CI/CD workflows have some challenges when it comes to digital engineering. They largely focus on software code and not digital models, where the code is co-located in a single or couple of repositories, unlike digital models that are distributed across SysML, CAD, PLM, ALM, project management, and a variety of domains. These traditional CI/CD workflow tools are pervasive, but largely focus on code actions like compiling your code, building your code, creating branches, and shipping your code. Each CI/CD technology brings its own language, kind of like a YAML-ish flavor, and it provides low-level file actions as opposed to API-centric data flows. Integrated digital engineering requires pipelines that enable API and data workflows, and here are some common patterns. An extract, transform, load pattern, where you can extract data from one model, filter and transform that, and generate or update another model and stitch digital threads between them. A report generation pattern, where you can extract information, filter and generate a report as a program deliverable. A digital threading pattern, where you can find correspondences and data across models and thread it. Or an analysis and execution pattern, where you extract system information from a model, run test cases, verify, and generate results and reports. And there are many such patterns for integrated digital engineering. So how do we finally realize this? We are the makers of the Syndeia digital thread platform that provides integrations to a broad set of digital engineering models and domains, such as digital threads, and makes this entire graph available to consumer apps using a powerful and comprehensive REST API. Syndeia provides dedicated integrations to digital engineering tools in a wide array of domains and connect with any enterprise tool or service that provides a REST API using its generic REST integration capability. All capabilities and integrations in Syndeia are available as API endpoints using a common unified data model. So whether you want to talk with Jira, GitHub, Teamcenter, or Teamwork Cloud, Syndeia API provides a simplified, unified gateway. We have been using Syndeia's API to build pipelines using traditional CI/CD tools, and something just didn't feel right for the reasons I shared earlier. The Syndeia 3.7 release in December brings pipelines as a native capability. In the next 3 minutes, I will show you 3 simple demos. The first pipeline pulls requirements from a SysML v2 model for a spacecraft using the standard systems modeling API and generates a report in Confluence. This can be configured to run on each commit, tag, baseline, or at specific time intervals. So within the Syndeia web dashboard, if you go to the pipelines page, you can look at that SysML v2 Confluence pipeline. You can see all the pipeline analytics, including its previous runs. You can see the pipeline in a tree view or a graph view. Although this pipeline is scheduled to run on a nightly basis, in this example, I can trigger this manually on demand. The graph view shows you a live animation as the pipeline runs through each step. We can see that animation on the tree view as well as the graph view. You can see which steps are complete, which are in green, and which steps are in progress. Once the pipeline finishes, you will automatically get a Slack notification with a link to the Confluence report where your requirements from a SysML v2 model have now been reported, along with the name of the requirement, the text, and an ID for each requirement. Simple example, but pretty powerful. The second example pulls assembly information from a SOLIDWORKS PDM model for a spacecraft and generates a mass property report in Confluence on a nightly basis. No more of manual or human-assisted extraction of this critical information. Latest mass properties are available for your entire team each morning to consume with your fresh brew. So here from your Syndeia web dashboard, you can go to the SOLIDWORKS PDM to the Confluence pipeline, which is visible on the dashboard. Once you go there, you can see all the previous runs of the pipeline and how each step did. You can see the pipeline in a graph view or a tree view. Although this is configured to run on a nightly basis, I can trigger this on demand. And now you can see a live animation in the tree view and the graph view. The green steps show you what's completed. The orange ones are in progress. Once this pipeline finishes, just like the previous one, I can get a Slack notification with a link to that Confluence report where a mass property table from the SOLIDWORKS model has been generated. You can see a flat list of parts here, but you can also have a hierarchical tree. It shows you the mass, the surface area, and the volume for each part. I can click on a hyperlink and it'll take me right to SOLIDWORKS PDM web viewer where I can pan and zoom and play with the part whose report has been created. Simple, easy, powerful for teams to collaborate on live 3D CAD data. The third pipeline is pulling system architecture information from a SysML v2 model of a spacecraft using the standard systems modeling API, and it generates a part structure in a Windchill PLM system, also possible with Teamcenter or ARAS, This can run per commit, per tag baseline, or at specific time. Again, same drill. You would go to the pipeline in the graph of the tree view. I can trigger this manually if I want. And so once I run it, I can see the live animation of the pipeline. It is extracting information from a SysML v2 model using the standard REST API. You can see the steps running through in the tree view or the graph view. And once it does that, it'll try to create parts in a Windchill PLM system. And once it's done, I can get a link to the Windchill PLM parts tree. And from there, I can browse the part structure that has been generated by the Syndeia pipeline in Windchill. So if you're interested to share your own pipeline AI use case or schedule a demo with us, you can meet either me or Lonnie or Greg here at the IW. And even better, you can scan that QR code and submit us your use case. We'll get back to you and share with you examples of pipelines that we have built that corresponds to your use case, or hey, we'll build one for you. Enjoy the event.